Okay, so ICS 2. D is the fourth quadrant portion of the unit, of the solid disk of radius 3 centered at 3, 0. So here's 3, 0. Disk of radius 3 centered at 3, 0 is going to be like this, and it goes around, etc. But I'm only interested in this fourth quadrant part. So I'm only interested in this. Right? Okay, yeah, right. Okay, so that being said, well, first of all, let's write down the equation of this thing. Well, the rectangular equation is x minus 3 squared plus y squared is equal to 9. And I claim if you plug in the polar coordinate formula, this is a lot like an example that we did in the section where you can take this and convert. No, this would be in the section way back in chapter
1.6,
something like that, where we're doing coordinate systems. Yeah, and you can convert this into polar. And you get that, let's see, so R is equal to 6 cosine theta, I believe. Yeah. Okay, is that cool?
Yeah.
Everybody good? All right. So we're interested just in this part. So, we're looking at a double integral of, some wacky function, x e to the y. We'll worry about this business later. But I want to worry about the bounds now. Integral being what it is. By the way, don't forget r d theta. Good news. Again, it's pretty much always r d theta. Don't forget that the r is not negotiable. You have to put the r there, but the dr is almost always to be on the inside of the d theta. And you can see why in this case r is a function of theta. So yeah, I want these bounds to be a function of theta. I don't want to have to solve for theta as a function of r, because then we're dealing with inverse trig functions and nobody wants that. Okay. So all right, so what's the range of values of theta here? Well, theta cross sections look kind of like this. And I claim we're going to keep getting theta cross-sections right up into the point where we have our lowest theta cross-section is theta 1 equals negative pi over 2. And then theta increases, etc. And your last theta cross-section is where theta is 0. Good? Everybody happy? So negative pi over 2 to 0. Okay, now for a given value of theta, so we're going to confine our attention now to one particular theta cross-section, and I want to know what's the value of r at the start of that, and what's the value of r at the end of that. All right, well, that's clearly r equals 0 right there. So, whoops, I almost wrote with the wrong color pen. 0. And the last value of r, well, I need to solve for r at that point. That point's on this curve. This curve has that equation, solve for r. Well, it's been done. So 6 cosine theta. Is that good? Okay. And the last thing, of course, you just plug in what x and y are in polar coordinates. X is r cosine theta. Y is r sine theta. Just plug in. Note that the problem just says set up but do not evaluate a double nested integral. So it becomes a double nested integral, and we're done.
Just a question in general.
Yeah.
So you always take your theta slices from the origin, right?
Yes, I mean theta is defined as angle from the origin.
Okay.
Yeah, no, it's always angle from the origin. That's right.
Because I think what messed up this problem, as simple as it was, I drew it wrong. What I drew, so I had, well, I guess you could probably just look at it.
Okay, sure.
So it's right here, this diagram on the top.
Yeah.
And that's why I didn't know what
Yeah,
to
no,
do.
that's right. So you had,
So
yeah, that's right.
Yes, I cut
So-
it like in a quarter because I thought like.
Right. No, critically, theta. So polar coordinates is set up in a very specific way, right? And that is theta is angle from the origin, compared to the x-axis, the positive part of the
That's what I was
x-axis.
confused because I was taking the
Yeah.
slices from the center point 0.3.
Yeah. Right.
0.3.
Yeah. Right.
3.0. So like I was wondering, okay, where do the theta stop? Like where do I take the r slices? That's what I was getting
Yeah.
confused.
No, I understand. Does that make sense now?
Makes sense because like
Yeah.
first of all I drew the picture wrong. So
And that's why it's in some sense what you were trying to do is you were trying to in some sense move the origin to where it would be more convenient, namely at the center of the circle, right? And it is more convenient. It's just not polar coordinates, and it's not. And if you have effectively a totally new coordinate system, then you'd have all sorts of new formulas to figure out. X would no longer be r cosine theta. Y would no longer be r sine theta. So you really want to stick with the pre-worked out, the already worked out polar coordinate stuff. Yeah. So you got it. So these are all very rigidly defined things. Yeah. Okay.